Hello, everyone. We'll give a few more minutes for others to join, and then we'll get started. Just a few more seconds here, waiting for some other people to join, and we'll go ahead and get started. All right, excellent. Well, I'd like to start out by thanking all of you for joining our webinar today. The topic is configuration compliance. It leverages our free and open source Golden Configuration app, which is available to everyone, and it's thoroughly documented. So feel free to get started once we finish today. Configuration compliance is a method of maintaining your configurations across your entire organization to a standard. The organizations which adopt this approach enjoy a network which is more reliable, has an enhanced security posture, and their administrators have greater control and visibility over those configurations. So with that said, let's take a look at the agenda here. We'll start out with some introductions. We'll transition into what configuration compliance is generally and how it's achieved. We'll talk about Nautobot's specific solution to achieving this goal and how you can get started, followed by a demo and a question and answer section. Now, feel free to ask your questions during the presentation. Just make sure you're using Zoom's Q&A function. There's a button at the bottom of your window there. You should see it. It says Q&A. So feel free to drop your questions in there. We have some upcoming public Nautobot workshops that I would encourage you all to explore. There's a link on the slide here, and then there's also a link in chat you can use to get to this section of our website. With that said, let's go ahead and transition over to the introductions. The presenter today is Tim Shriak. He's the Director of Sales Engineering here at Network to Code. My name is Chris Murray, and I'm a Senior Technical Marketing Engineer at Network to Code. So I'll go ahead and transition it over to you, Tim.
Thanks, Chris. Welcome everyone here that's out in the audience. Glad you're able to join us today. And as Chris said, today we're going to be going over configuration compliance, first taking a look at kind of an overview of the challenge and sort of the why. Why do we need config compliance? The notion being here that we have all of our devices out in the environment, in our legacy, kind of traditional world. And when we manage things by hand, it is inevitable that we have little errors here and there. It is very difficult to keep a large or even a mid-size environment in line with our expected standards by hand, right? There's just always going to be drift. And as soon as you start to scale up in that, it becomes really difficult to manage, in the sense of like, traffic in a blizzard, right? It's really hard to manage that scenario when we have that sort of consolidation. So really the idea here we're looking at is treating devices as cattle, not pets. We want to treat them as a large group and treat them as uniformly as possible. Why is it hard? Really, here we have so many different things that we're struggling with from the network perspective that really makes us unique in our space compared to, say, the other tech areas, whether we're thinking about compute or storage. The complexities that we have on the network side are much higher than in other areas. So things like, for example, the syntax that we work with, vendor, it varies by model, by vendor, by location. There's so many different forms of syntax that we deal with and we struggle with from the standardization perspective. And then we have the data side. We have so much more data to deal with than anyone else in our space. A single one of our devices probably has, 48 interfaces on it, very common example. That's 48 pieces of data that I need right there. never mind all of the sub pieces of data that I need in order to configure that particular interface, right? So there's just a lot of data needed that we have to struggle with and that we're trying to standardize and minimize the variance from the standard in. And often after change, we need to make adjustments to it. That's how we instantiate change in the environment, is making changes to these, whether it's the syntax or the data side. And of course, across all different kinds of changes that we create in our environments, right? Whether it's we're doing an update to the environment from a technology perspective, say, going from layer 2 to layer 3. Perhaps we're doing a model upgrade, on the equipment, platform transitions there, OS upgrades, right? Something that we are always constantly doing and involve change. Incidents that occur and we have to remediate them. There's a problem, we need to fix it. And then just standard moves, adds, and changes, right? Your standard configuration changes, right, as well. And then, of course, along with the topology changes that are occurring, just some examples, right? And there may be others in your environment. So kind of looking across the scope of the ways that we deal with this problem, of the way that we try to instantiate config compliance. We have kind of the standard CLI-driven method there, reactive discovery. That is, we find there's a problem, something breaks, we get caught in an audit, we go and we fix it by hand. It's not a very effective method. In fact, for sure, our environment will not be in compliance with our standards. And, maybe it has a reasonably low cost of ownership, but it has a very high risk associated with it. Then we can move into something maybe a little bit improved, going with some scripts that we might write that we can help kind of run those on a regular basis. The challenge with these, though, is maintaining them. They're really difficult to maintain as we have those kind of, whether any of those updates that we just talked about, whether it's a configuration update, whether it is a new vendor, or maybe even just we're doing an upgrade from model to model, right? Like we know a lot of the vendors, when you make those changes, there are syntax changes that come with that. Of course, there are some commercial tools out there that seek to solve this problem. They tend to be quite effective if actually used and built properly. The challenge in this space, though, is that they tend to be quite limited in their scope of extensibility. They have the things that they can do out of the box, and that's all that they can do, as well as there's a lot of effort that goes into implementing them. So much so that, in fact, a lot of the clients that we speak with, they may have actually purchased a tool that does this, but don't actually use it to its full capacity, or maybe even don't use it at all because it's so difficult to use. And then we move over into what we're calling here net DevOps compliance. This is based on free and open source tooling, really extensible. And the notion being that we're actually taking the concepts of DevOps and applying them to the network space in such a way that we can take advantage of all of the powerful aspects that come from the DevOps concepts, things like source of truth, for example, and incorporating that into our flow. Extremely effective, and really reduces our total cost of ownership, because now we can actually have a tool that does the job we intended it to do as well. So how do we actually achieve compliance? This is the nirvana state that we're looking for. It is always going to require a source of truth. And the reason for this is that we want to create two different abstractions when we come to network devices in order to do compliance. The first abstraction is the data side, and we store the data in a source of truth. And when we say a source of truth, now, in a technical perspective, this could be anything from a YAML file, if you will, to a full-fledged database. And that's all fine and good if you're at a conference and you're giving a talk. But in a practical perspective, it is impossible to maintain something like a YAML file in any kind of a scaled environment. Even at a reasonably small scale, it becomes very difficult to maintain flat files. One, we can't really create relationships between the data that we have in those flat files, or it's very difficult to do so. It's difficult to update, and it's difficult to use. So really, from a practical perspective, when we talk about source of truth, we're talking about a database. That's really the only thing that works in the real world. So here's an example of what we might look at as far as the way that we would store data in a database coming from the real world into the data model that we need in order to use it in some form of SQL database. So kind of looking at that source of truth a little deeper, we want to be able to define the data in an authoritative place and then get it back as needed. So the goal being that we're going to input the information about our environment. We're going to model our environment in the data so that it's available to us when we actually are going to do config compliance and generating intended configuration from our intended states. This allows us to do things like standardize and have continuous verification of the data. We can actually make sure that the data is what we intended it to be. Allows us to do things like peer review, like when we make an update, we can check that data and make sure it was correct before we do a push out into the environment. As you look kind of down there in the lower right-hand side of the screen, you'll see some ideas behind how compliance might work, where we're saying, hey, this section of configuration is non-compliant, but this part is. So really helping us break that overall file or configuration for the device into its relevant sections. Notice just a little key thing we're highlighting there too. Under that non-compliant section there, we have some missing configuration and extra configuration. And this is a key thing to ask yourself about any tool that you're using to do configuration compliance in the network space. We face a unique challenge with our devices because they are configured with one monolithic flat file. And this is unique to us in network devices for the most part. So when we say missing config, what we mean by that is the configuration that is expressed in the intended state, in the intended standard, and is missing from the device, right? So that's the missing configuration. It's in the standard, it's not on the device. Pretty much every tool that does configuration compliance does that. That's the expected table stakes for a tool. Extra configuration. This is where it gets interesting. This is configuration that exists on the device that is not in the standard. And this is a difficult problem when it comes to network devices. At first glance, it might seem obvious because if you think about the practical aspects of this, that is extra configuration. So perhaps we had an old circuit, we discontinued that circuit, and we forgot to remove the configuration from the device. So that would be extra configuration, right? It's not intended to be there, but it's still on the device. And it seems obvious, our tool should tell us that. But that's actually hard to discover on a network device because of that flat file. So in order to do that, a tool has to be section aware for that particular vendor syntax. So you need a flexible framework that allows you to describe what sections look like for a particular device, for a particular model, for a particular vendor. And this is something unique that is really difficult in our space. So this is something really important to think about when you're looking at compliance tools. Does it allow me to discover this extra config? Because this is a common real-world problem. It's also the way we're generally exposed to vulnerabilities. That is, we left something out there should not be there, and we need to remove it. But discovering that can be difficult, especially in larger environments. So this is what we're looking at from the standardization, the ability to look at the intended state that the device should have, compare that to its actual state, and report on that. So how do we solve this using Nautobot? If you're not familiar with Nautobot, it is the open source project sponsored by Network to Code, free and open source available to you. You can go download it today. And of course, we're always here to help you as well. But let's take a dive into configuration compliance from the Nautobot perspective and how we have implemented it in the Nautobot framework. At its core, Nautobot is a source of truth database. That is the core functionality of Nautobot and what its purpose it serves. But on top of that database, what we did is add a layer that allows us to develop applications intended for automation purposes. And our config compliance solution is one of those apps. So it allows us to express our intended configurations, what they should look like. We can extract the actual configurations from the devices. And then we use our configuration compliance engine to do the comparison between those two states and produce the output for the discrepancies. Thinking of the source of truth component of Nautobot, it gives us a place to aggregate data from our environment. So we have things like, perhaps in your environment, you might have things like Infobox, maybe Arista Cloud Vision, Cisco Meraki would be another example, ServiceNow CMDB, IP Fabric, Device 42, right? The list goes on and on of other tools that you might want to extract data from and bring them into Nautobot as a layer of data aggregation. We can also use other components of the Nautobot ecosystem, things like the onboarding app or the network importer. These are tools that allow us to go and extract information from the existing network and bring them into Nautobot. In the upper right corner there, we see our configuration templates. These are the expressions of our intended syntax, right? So that abstraction. On the left-hand side, we're looking at more of the data side, the data abstraction. On the right-hand side here, we have the configuration abstraction. And then finally, those entities that we're actually defining, that is the data model. And a key thing to think about or understand with the Nautobot framework is that it is intended to be extensible and flexible. So you'll notice under each of the data models that we have there, whether it's inventory management, IPAM, VLAN management, et cetera, we always have the ability to add custom fields. And those are extensions of the model, right? So this allows us to make the model flexible, make it work in your environment without actually breaking the model for future upgrades, right? It gives you that capability to extend it to what you need. How do we get the device's state? That is, what's its actual configuration right now? We have two methods. One, we can use Nautobot itself to go out and do that. We have implemented under the hood the capability to go and extract the configuration from a device and store it in a Git repository. But being a really flexible framework, it is not a requirement that you do that via Nautobot. If you've already got some other tool doing your backups, maybe it's Rancid, for example, that's great, no problem. All we need to do is get those backup files into the Git repository that Nautobot has access to, and we can get access to those backups. So really flexible choice there. If you want to consolidate your backups into the Nautobot platform, you can. But if you already have another tool you like, totally fine. You can keep using that. Now, the configuration abstraction and the intended states, how do we get there? So we're starting off with the data, right? That's the source of truth data. That's the data abstraction we have there in the upper left. And then our Jinja template that's giving us the intended syntax. In this example that we're showing here on the screen, we're showing you a medium complexity Jinja template, for example. You know, there's a for loop in there, and you can see that we're referencing some data that's back in the database with those variables that are listed there. The Nautobot platform is bringing those two things together and then producing the output on the right, which is the intended state for this particular device. Key thing to note here, we are using the Jinja templating format. Of course, that is part of Ansible. And if you are familiar with Ansible and doing that, you know that in order to say, get access to those variables, I need to do several things. One, I need to have an inventory file. I need to define my device vars, my group vars, and all of these different files and maintain those. When you're working within Nautobot, what we've done is abstract you from that problem. You don't need to worry about that Ansible overhead. All of that's being handled for you by Nautobot. So no need to maintain an Ansible inventory file, no need to go create group vars and device vars. You have all of that power of the source of truth available to you, so we don't need to do that by hand. So it really eliminates a lot of that overhead and that busy work that comes from using Ansible if you're just doing it directly. So now as we look at the different sections of configuration, here we're thinking about how do I say and create my data abstractions? So for example, I know that I want my device configuration to list out these particular name servers, and I know that I want these particular NTP servers. So how do we get to this state of this particular data? And this is something we have here in a combination of the syntax that's coming from those Jinja templates and then the source of truth attributes. So for example, we could say, hey, you know what? We want our NTP server to be globally defined as 1.1.1, for example, or perhaps, you know, some other IP address. But you might say, hey, in certain cases, I need to override that. Maybe in data center A, I use a different NTP server. Or maybe in a different region of the world, I use a different NTP server, or any other number of variables. And those are those source of truth attributes, right? So those allow me to have some flexibility in the way I define things. I don't need to define things on a per device level. We're trying to define things at a much higher abstraction. So it saves us time, makes that a lot easier. Now the comparison. This is what I was alluding to earlier about the notion of the missing configuration and the extra configuration. So here we can see we've got that intended state coming from the merge of the configuration template and that data coming out of the source of truth. And then the actual state of the device that we have from the backup file. The config compliance engine is going to do the comparison of those two, extract the appropriate section of configuration, and give us the resulting output. So you can see down there in the bottom, we've got those red sections of missing configuration. This is where we're missing these particular items from the actual device. And in the extra, here's some stuff that should not be there, that is not in the standard. So making it as simple as possible for you to consume, whoever is responsible to say do remediation, they can quickly, easily understand what are the differences and why are we reporting or flagging on this particular section of config as non-compliant. Here's just some simple screenshots. We will go through here in a demo in a minute as well. We'll get a deeper dive into some of these, but giving you an idea of what the tool looks like, starting in the upper left here, the dashboard view. Just kind of a quick view. You might have this up in your NOC, or maybe your help desk might have this available. In an ideal state, we would have everything green, right? All green check marks across there. Anything red pops up, we know we need immediate attention there. Of course, when we first roll out a tool like this in an existing environment, probably there are going to be a fair amount of things red, and that's okay. That's probably to be expected, and we can work on that over time to get our environment into compliance. We also include things like a status page, so we can see, the last time something was backed up, the last time we rendered intended state, the last time we ran compliance against it. So we can have that awareness there, as well as just the state of how are we doing with compliance. Are we making sure that we're running on all the devices like we should? And then finally, the detailed view of a particular device, right? So here we're looking at a particular device and its compliance states and the sections of configuration that are in compliance versus the sections that are not. So we have all of that available to us here in the UI of Nautobot. So where might you get started? And the notion here is start somewhere and start today. Don't wait. There's no reason to wait for this. We can always get started as soon as possible. Start with something simple and iterate from there. So starting with things that are easy to do, maybe your NTP server, enabling secret, your banners, the types of things that are not particularly complex. Moving on to, say, medium complexity, things like interfaces and SNMP settings, AAA, maybe a little bit more complexity in our definition of our intended state, and then the actual rendering of those configurations. And then finally, moving on to the more complex sections of configuration, things like BGP, ACLs, et cetera, that are going to take some more time and also going to require you to kind of level up your Jinja templating skills as well to really do that efficiently. Of course, you don't have to be efficient in your templates, but the more you are, the more reusable they are, and the more time you can save yourself. So let's dive into a demo here and start taking a look at some of this work. And do feel free to fire away questions into the Q&A as we go through here. We're always happy to answer those. Good to see the interaction from the folks out there as well. So I am going to use our public demo instance here for the webinar. So feel free, you can also log into demo.nautobot.com after the webinar. And the credentials are right there up at the top for you, so you can log in and check it out as well. You'll notice here we have the golden configuration section here up at the top, and this is where we're starting off. So we're looking kind of here at, again, at that NOC view, that high level summarization, somewhere where we can just kind of get a good sense of what's going on out in the environment. I want to highlight a couple of things on this screen. You'll notice across the top of the page that you're seeing sections of configuration relevant to a network device. Key thing to note about these are both not requirements and they are not limitations. So that is, I do not have to do all these things if I don't want. The framework is very flexible. And I can do more than just this. So for example, as you look down the left-hand side of the screen, you will notice examples of switches and routers. But that's not a limitation of the tool. The tool can handle switches and routers, obviously, but also load balancers, firewalls, even Linux servers could all be modeled here in the tool. And actually, even things like cloud controllers. So whether you're using Arista Cloud Vision, ACI, Meraki, any type of controller, we can actually model the input to those tools as well. So really a lot of flexibility how you might use this tool in your environment. And something I always like to recommend for people just kind of starting off with this is, as you work on this, I would suggest you start with 1 or 2 items of configuration. Start there, start simple. Maybe you do DNS and NTP to get started. Probably it's going to take you a little bit of time to learn how to define your intended state, so you can practice that. And then as you roll it out, you're probably going to have a lot of red X's. That's just the reality. So that gives you time to say, hey, I'm going to do DNS first. I'm going to learn how to create my intended state. I'm going to roll it out, and I'm going to find out where all my red X's are. I'm going to go get my environment and compliance, get all my green check marks, and then I'm going to go on to the next one. Then maybe next I do NTP or whatever makes sense in your environment, right? Like, maybe you have an audit coming up and you're like, I really need to make sure this is fixed. Deal with that first. And then gradually expand. And what's really cool about this process is what it's letting you do is gradually move from operating your environment via the CLI or the UI to eventually operating your environment from infrastructure as code. Because as you define your intended states here in the tool, what you're doing is creating your configuration in code. So by the end of this, you are actually able to make that journey from CLI driven to full infrastructure as code modeling here in the configuration compliance tool. So this is a way that we can help enable you to make that transition and to take that journey. Because commonly when we think about this journey, it's a really difficult challenge to go from, hey, I operate the environment via CLI to I operate the environment via infrastructure as code. Let's kind of dive into one example here, just to get a little deeper view of this particular device. And here's an example of this particular spine out in our Jersey City environment. And we can see, hey, we're compliant for NTP and logging, which is great. But as we roll down to the interface section, we see that we're non-compliant on the interface, similar to what we saw in the screenshot earlier. We have some missing config. This information is defined in the intended state. And here's the extra config. This is the stuff on the device that should have been removed. Forgot to sunset these VLANs and these interfaces. So how did we arrive at this intended state? How did we get to this? Let's take a look at those 2 different abstractions. We have the device data abstraction. So we're going to start there. So let's dive into that device. We'll just do a quick search for that Jersey City device and bring that up here in the UI of Nautobot. For those not familiar with Nautobot as well, this is also a little bit showing off the underlying database and the power that it has, right? Being able to model everything about this device here, both from the CMDB perspective, the DCIM perspective, the IPAN perspective, and pretty much all aspects of this device can be modeled here in Nautobot. A lot of power here available to us. If we give a little scroll down, we can see first, we have some examples of sections of config, so we can kind of see this detailed view. I imagine this is probably more relevant to an engineer. The other screens may be more relevant to someone working in the NOC or operations. But as an engineer, I can look at this particular device, quick glance, see what's going on here. Where is its status? This, I think, is one of the best views, this compliance details report. This gives us a diff between the actual state and the intended state. Helps us understand maybe why we're getting this flag. Maybe it's not as obvious to us when we're first looking at that original screen. It also shows us a little bit of the power of this tool. We can see things like, for example, we can ignore stuff we don't care about in the backup file. So we're not going to alert out on, like these backup commands, for example. Or the same, we decided here in the demo environment in this example, we don't ever care about the limit resource command. We want to ignore that. We don't want to flag on that. This is really valuable because whenever we get false positives from a tool, we generally ignore everything coming from that tool. So this gives you the ability to make sure you don't get false positives. You want to only be flagging and alerting on things that actually need to be corrected. We should never be in the mindset that, oh, that's a red X, but it's okay in that one case. Don't worry about it. We should either deal with that problem and fix it or eliminate the red X. Say, you know what, that's fine. We're going to ignore that for now. We don't care about that. We don't want to have any red X's on the screen that don't need remediation. That's a really important concept we need to think about and a little bit of a paradigm shift that we need to make if we want to have full functionality and use from tools like this. coming back to the main screen, we do see, for example, we can look at the fully intended configuration that's being generated by the Nautobot platform here. And in this case, we are rendering the complete configuration for the device. We have actually made that journey to full infrastructure as code here in the demo environment, right? So just as an example to show that it's possible. And then as a one-stop shop, if you will, we can also see the actual state of the device. Just a simple place to come and see all the things. I don't necessarily have to go to my other tool if I'm doing backups in a separate tool to see the, a rendered the actual configuration coming from the tool. So just kind of simple there for us. And then finally, now into the data piece, right? So this is the data that we have rendered for this particular device. And I'm just going to show you this example here of this JSON blob, if you will. We also have kind of some nice flexibility within the UI. We could also pivot that to YAML if we want. If that's a little easier for you to read, you can see it in YAML. So very easy to do here, flipping between JSON and YAML. But we can see all of this data that we've rendered here from the platform and potentially from external sources. Right? We're not limited to gathering data just from Nautobot. We can actually get data here from other sources as well. Perhaps something like a YAML file that we might have in a Git repository. We can extract data from there also. So this is that rendered data. Now, where did this come from? And that's kind of really the interesting bit. And this is the part about data abstractions. So in the Nautobot universe, we use a concept we call configuration contexts. Configuration contexts allow us to start thinking about data more abstractly. I'm going to start from the bottom up from this perspective. If you think of object-oriented coding, right, we define a parent class, and then we can have child classes under that parent where we inherit the properties of the parent. Config context works something like that. Another notion could be, for those of you that are network engineers in here, you think of the BGP route selection method, right? We have those different standards by which we choose which route is appropriate. And this would be what we're looking at here is the local context. This would be the most preferred route, for example. So here in the local context, anything defined in the local context is going to win, right? It's going to be always applied to the device. And so we want to define things here that are relevant to this device and only this device. For example, BGP neighbors, great example of something that is relevant to only this device. Perhaps in this case, we showed an example that we wanted to set a very specific route on this device as one example as well. But then we're going to try to move up the chain of these contexts. We'll kind of go now all the way to the top of the chain with our global definitions. So this allows us to say, you know what, we're going to set some defaults across the environment. By default, we want to say CDP is enabled, LLDP is enabled, and these are our NTP servers across the environment. And there's a few more things here in the example as well. So it kind of gives us this one place to set things globally. But then we have this preference identifier over here for the context that we can use to create child contexts, if you will, or more specific contexts. So we can do things like say, hey, if it's NXOS, we're going to set these particular SNMP strings. Or even potentially, we could override those NTP settings or SNMP strings that were set up here at the global level. Or we could say, hey, because it's a spine, so the role of the device, let's set some particular variables, some data here. And any other number of criteria could be here. Is it in a particular data center? Is it in the US or is it in EMEA? Is it in a particular rack? Right? So a lot of flexibility, how you can use these configuration contexts to define your data, to define what is my NTP server, what is my SNMP string, what are my routes, et cetera, right? So it gives you a lot of flexibility to kind of define globally at a high level and then override as needed. Because as we all know, there's always these little one-off scenarios where, hey, I need to override this in one particular case. So this is the data side of the world that we're using here in the config compliance tool. Now, then we have the other layer of abstraction, which will be our templates, our intended configurations, or sorry, our intended syntax that we want to apply to the device. And the way that we do that is by linking in Git repositories to the Nautobot platform. So we can specify a repository, and here you can see an example that we're going to use for our backups. This is how we're getting the actual state of the device, as we mentioned earlier. And essentially what we're doing is we're saying, hey, this particular URL, this particular repository, it provides the purpose of backups here on the Nautobot side, right? That's what we're doing here, making this connection between the repository and what purpose it serves for Nautobot. And then we can define one for our templates. So here we have an example of our template repository and the purpose that it serves over here on the Nautobot side as well. So let's go ahead and take a look at that URL just for our purposes here, and we'll see what that looks like here in the environment. So kind of drilling and starting at the top level, we can see some examples of here where we've used the operating system of the device to define these states. So let's drill into a simple example with NXOS. I'm going to look at a DNS, for example, because I think I like to highlight this notion that, templates don't have to be complex. They can start off really simple. Here's a template that has no code in it, has no variables in it. It's literally just the syntax I want to discover on the device here in the template. So really easy. You could do this today. There's nothing complex going on here right now. This is just very basic template. And sometimes that's all you need. You don't necessarily need complexity. But then as we kind of move up the chain, let's look at something maybe a little bit more complex, say some medium complexity. Here's an example for NTP. So here we're using some for loops, some if statements, and we're referencing those variables that are over in the Nautobot side of the world, that is that configuration context. So we're able to access all the data in that config context here in our Jinja template. So I don't, again, as I mentioned earlier, don't need to worry about that Ansible overhead. I don't need to define those group vars, those device vars, all of those components, right? Like those are all available to me when I write my template. But you can see here, we are still including some vendor syntax in this particular template. So that means that this template is definitely going to only be applicable for an NXOS device or any device that complies with this particular syntax standard. But perhaps as you get more fluent in using Jinja and you want to start to become more flexible with your templates, we can do things like include statements. This gives us a tremendous amount of power when we start to write our templates, because now I can include the appropriate sub-template based on what I need. So here we're looking at a template that's rendering interface configuration for an NXOS device, but it can handle any type of device that we might think of as far as interfaces go. It could have any number of traditional interfaces, regular LAN interfaces. It could have any number of physical interfaces, any number of management interfaces, any number of loopbacks, for example. So really flexible here. I can use one template for all of my NXOS devices in the environment, regardless of what they actually look like, whether it has 32 ports or 48 ports, no matter how many SVIs I configured, they're all here for me. And I can just use that data that I have to actually render the appropriate configuration based on the code here in the template. So a lot of flexibility and a lot of power. The other kind of cool thing that happens from this is standardization. That means that I know that the configuration for all my SVIs, all my physical ports, et cetera, is going to be the same because I'm rendering it from a single sub-template. And then when I need to make an update, maybe we've decided we were going to change our description format or what have you, I just go to one place to make that change. So it really simplifies those kinds of changes. I just do something once. I don't have to do it repeatedly. So this is how we're making that merge between the actual data on the device, the intended state coming from Nautobot, and our configuration that we have here in the Git repository. Just coming back for one final view of looking at this side of the aspects of config compliance, coming back to the notion that what we're looking at here on this stage of configuration compliance is the reporting aspect. It allows us to render our intended state and create the actual report and the diff between what we expected to create and what is actually out there. As you think down the road, a common question we get is, can we also do configuration deployment? That is, can we remediate the device? And yes, that is absolutely possible. And something that takes a bit of a journey. Right? First, we need to get this side of compliance up and functioning correctly. We need to have our source of truth updated and accurate. And then we can make that transition into configuration remediation and configuration deployment. But those are further on steps that will be beyond the scope of today's webinar, but are absolutely also interesting concepts as well. So just wanted to highlight that today we are focusing purely on the configuration compliance and reporting aspects. That concludes the section of demo that we was expecting to go through today. And now going back over here to Chris and seeing if we have any outstanding questions that we want to talk about here live at the end.
Awesome. Thanks for presenting that, Tim. It's very informative. We'll go ahead and open it up for a question and answer section. We did have one question come in from Patrick Cohen here regarding importing the configuration from devices and how that's done. From what I understand, that's not functional in the demo instance today, but maybe you could speak to that for a few minutes.
Sure, yeah. So we do absolutely have the capability to go out and collect data about the device and bring that into the Nautobot platform. So populating the source of truth with the data, that is how many interfaces, what's its serial number, et cetera, those types of things, absolutely possible using either the network importer or the device onboarding plugins that are available as part of the Nautobot ecosystem. Importing configuration itself, that is the syntax, we really don't recommend to do that. And the reason is, let's say that I went out and looked at two different spines in your environment. It's most likely possible that as I look across the spines in your environment, I am going to find slightly different configurations from device to device. And from a code perspective, how do I know which one is correct? We're going to have to punt it back to you as the human to figure that out. Generally, what we find, it's better to start from what do you expect to find on the device? So define your intended state from a configuration perspective, and let's go compare that to the actual real world, as opposed to trying to import that piece of data, or sorry, that configuration from the device. Hopefully that makes sense. What we do see commonly with clients, what they will do is they will find a device that they believe is pretty in line with their intended state. Let's start from there. So basically, we start creating that Jinja template from a device that we think is pretty good and start creating the template from that. So hopefully that helps answer your question that we can absolutely import the data, but we recommend the configuration. We actually start by expressing that. Any other questions, Chris?
So that looks like all the questions. Maybe we'll give it another minute or two just to see if there's any questions that are still coming in.
Yeah, feel free for anyone out there. If you have some questions for us, please do fire away. If not, thank you very much for joining us today for our brief webinar on configuration compliance. Please do reach out to us if you are interested and would like some help in implementing this in your environment. We're always here for you. And of course, you're welcome to go download the project at Nautobot and start working on it yourself today as well.
I think that about does it for questions, but feel free to reach out to us after the webinar, and we're happy to answer any questions you might have. I would like to thank everyone for joining today, and we hope we get to the next one as well. Appreciate it. Thank you.
Thanks, everyone.